Hello guys, so we have another problem, removing digits. This is one of the very easiest problem in the CSES set. So you are given an integer n, and in each step we can subtract any of the digit from it, and we are required to find the minimum number of steps to make the number 0. So let's say we are given a number n. So before this, let's check the base cases. Like if the number is already 0, we need 0 number of steps. If the number is 1, we can directly subtract 1. Like if it has only one digit, we can directly subtract 1, and in one step we will reach 0. Similarly for 2 and up to 9, all will get reduced to 0 in just one step, right? Now we have two digit numbers. So the first two digit number is 10. Now we have different choices that we can reduce it by the first digit or the second digit. So if we reduce it by the first digit, so we reduce something, so steps increase, and the number new number becomes 10 minus 1, that is 9. Or else we can reduce 0, so the steps increase as we are reducing something, and the number remains 10. Is this any fruitful? No, right? So let's to cover up this case, that if we subtract 0 from the same number, we would not reach anything. So this would require infinity steps, right? And as we know that, and for this case, as we already know that 9 takes one step, so 1 plus 1 becomes 2. So this is our answer. Similarly for 11, let's see. Either we can reduce 1 only. So whatever we use, so 1 plus the remainder is 10. This is the number of steps. So for 10 we require 2 steps. So the answer would be 1 plus 2, that is 3. So if you see that, let's say we have some number, any number, when let's say it also has a 0. So if we reduce it by 0, it makes no good. So let's keep that infinity, because let's say that the initial state, that the number of steps to reduce this number, let's say we have a dp, alright, we store the number of steps to reduce to 0. So initially we'll have, let's say this is n, so we'll keep it infinity. So, and before this, we we will calculate all of the minimum number of steps for all of the numbers before it. So basically up to n minus 1, we have all calculated it. So how are we passing it is, now let's say this is the number, either uh, using 0, the dp, let's say the answer, possible answers is dp of the same number. Now if we reduce by this digit, so it becomes 1 plus dp of n minus 7. And as we have already calculated up to n minus 1, this will be some value, let's say v1. Now we can reduce it by 9, and let's say it has some value v2. And similarly, we'll take all the cases, and the minimum of all the cases, basically the minimum of v1, v2, up to number of digits, let's say 5, v5. This will give us the value required for digit n. So this is the simple approach. We'll start from 1. For 0, it's already 0. So we'll start from 1. And for each, we will follow the same process because the digit is the number of digit maximum can be 6 or 7. So 0, 0, 0, 0, 0, 0. So maximum number of digits will be 7. So at max we'll have 7 digits. So let's see how can we implement this in code. So as we said, we'll initialize a DP and fill it with infinities. We know that to reduce 0, we need 0 steps. And from then up to end, we will calculate for each number. Now for easy parsing of the number, I converted it to a string. And for each character in the string, I will check if that I minus the character yields the minimum value. And I'll take the min of all the values. And at the last, I'll just output the minimum number of steps for n. I hope it is clear. It is an easy problem. Thank you.